light beam. See beta, as you are seeing this term, that is parallel. So the rays of light have this kind of pattern. Okay, these are the parallel light beam. And what is the beam? Beam is the broad collection of the rays, and these are the parallel light beam. Why are they called parallel light beam? Because of they are having equal distance. They are having equal distance among them. If this one is 5 centimeter, this one is also 5 centimeter, and this one is also 5 centimeter. So first one, equal distance among them. Okay, and the second one, they will never meet with each other at any point. They will never. So second one is they will never meet to each other at any point. Whether we will move to forward or backward, they will never meet with each other to each other at any point. So these 2 points is very important. These 2 points are very important for the parallel light beam. Now we will move to the divergent light beam, the second type of the beam of light. See, second one. Second one is divergent beam of light. See, listen. See that first word, divergent. It's something like diverge. You have seen lots of the time on the road. See, there is a written diversion ahead, or there is a diversion. When your straight road is moving or turning some other direction, then there is a board, there is a notice board, there is a diversion. So diversion means if you are leaving your main path, if you are leaving your mainstream, if you are leaving your straight line to the other direction, that is known as diversion. So divergent beam of light. See, this is the figure of divergent beam of light. See, how can we say that this is a divergent beam of light or divergent light of beam? See, it originates from the single source but spread out in each direction. In all direction, it is spread out. Means it diverge in all the direction. So what is the divergent beam of light? When any rays were on, or any collection of rays originate from single source and spread throughout the direction, throughout all the direction, that is known as divergent beam of light. Okay, as like you have seen in sun. Sun is the example of divergent beam of light. From the sun, all the rays spread out throughout the earth. Each and every corner, each and every surface of the earth just surrounded from the sunlight because of this property, divergent beam of light. Okay, now the next one, the convergent beam of light. Now convergent light beam. See that first word, convergent, means converge. Okay, see what is the meaning of the converge? When lots of area of rays just meet at a single point. They come and meet at a single point. That is known as convergent light beam. You better understand from this figure. You can say it has opposite nature of divergent ray. See, this is a intersection point of all the rays coming to the one single point. That is known as convergent light beam. Okay, these are the three types of beam of light. So we have covered ray of light, we have covered beam of light, we have covered parallel, we have covered divergent, and we have covered convergent light beam. Okay, we have in each and every time we have discussed about a source, light source. Okay, to belonging to that source we will study about point source. Okay. Now point source. So what is the point source? See, source of light, there is a source of light which is the same size of a pin. Means if we are taking this one as a pin, then tip of this pin is a point source, of light. If any source of light has this size, pin size, that is known as point source. And except this means larger than, greater than point source, all the light source known as extended source of light. Means except this point source, all the source of light is known as extended source of light. As like sun, as like CFL, as like LED, all are the example of extended source of light. See, extended source of light. Sun is the example of extended source of light. Bulb is also example of extended source of light. Okay, CFL, tube light, these all are the example of extended source of light because they don't have the size of that pin. So except that pin size source of light, all the known as extended source of light. Okay, now if light falls upon something, whether it after falling on that surface, whether it will reflect or it will cross that surface and just go to other side of that surface. There is only two conditions, whether it will come to this surface and reflect, or it will come and cross this surface and go to the other side of this surface. So what will happen when both two phenomena will follow by any surface? So from today's topic, we have covered point source, we have covered extended source. Now image. I will show you the definition of image by an experiment. See, this is a marker pen, okay, and light is coming on this marker pen, and see, it has a black shadow on this board. See, this one is a black shadow. This one is the black shadow of this marker pen. So this is the image. This one is the image of this marker pen. Okay, it is possible because of light falls upon this surface and reflect or refract. In both the condition, we will get an image. Okay, so if any ray of light falls upon surface and reflected or refracted on the surface, forms image. Okay, so what is our main concern? Main concern is reflection and refraction. Reflection and refraction. So be very attentive. Because of these two terms. Whenever you will read physics and chapter light, both two terms have a very important role in this chapter light. Okay, so we will discuss this reflection and refraction. So what is image? Any ray of light falls upon the surface and reflected or refracted on the surface forms image. Okay, now reflection and refraction. See, reflection. What is the reflection? See beta, it is a surface. It is a reflecting surface. And what is this arrow? These are the polish. Okay, this is a reflecting surface, and one ray of light falls upon this surface and reflect. This is the phenomena of reflection. Every one of you is watching in every morning your face in the mirror. That is because of this reflection. Because of reflection, light falls upon that mirror and comes to your face, so you are able to see your image in that mirror. Okay, now the refraction. refraction. This is a surface, okay, and one ray of light. One ray of light falls upon this and it will cross. It will cross that surface in both the condition. This one is known as refraction. In both the condition you will get an image. You will get an image. So what is the difference? You are easily observing that in this condition light is not crossing this surface, just reflect back, just return back to the another direction, and in this condition light is falling upon the surface and it cross that surface, okay, and go in another direction. Okay, now from both the phenomena, reflection and refraction, we will get image. But there is two type of image. One is real image and second is virtual image. One is real image and one is virtual image. So this is the type of real image and virtual image. We will discuss about this real image and virtual image in next lecture. So don't miss the next lecture. And once again I would like to remind you that do not forget to subscribe, like and comment our channel. Okay. So in next lecture we will discuss about real image and virtual image, which is